Okay, in this video, I'm going to look a little more at law of cosines, and I want to do at least two problems here that have some things in them that can be a little tricky, okay? All right, so if you were doing this problem, you would definitely want to use the law of cosines to find little a. That's how you'd have to begin. And it's because of the information you're given, how you know angle A. So you want the version of the law of cosines that has angle A in it. Okay, so we're going to plug in what we know to find the A. So we know B is 4, C is 8, and then angle A is 46 degrees. So we'll put that in there. All right, and then I recommend really that you go ahead and type all that in and don't round off too much at that point. Wait until after you do the square root to round off. So we're going to do 4 squared plus 8 squared plus 2 times 4 times 8 cosine. Make sure you're in degree mode. And we get about, okay, that was supposed to be a minus. I was looking at what I had entered and caught a mistake. So let me fix that before I tell you. And I get about 35 point, I'm going to keep at least 2 written down here, but actually on my calculator, I like to hang on to all of those accuracy, all of those decimals that are on my calculator. All right, and then I do the square root of what's sitting on my calculator screen, and I get that A is about 5.96, and if we round to the nearest tenth, that would wind up being about 6, okay? So I'm going to fill that in over here, but let me do that in a different color so we remember what we found and what we were given. All right, so now at this point, we normally jump to the law of sines, and you're really going to want to do a particular one, but let me show you what can happen and then why we need to approach it the way I'm going to tell you. All right, so what if I went in and I'm looking for, let's say, angle C. Since I'm looking for angle C, I want to put that on top left, because it just makes the algebra a whole lot easier. And then I'll put that together with the information about the A pieces. So sine of 46 over 6. And then I'm going to work that out. Okay, and when I multiply both sides by 8, I get that sine C turns out to be about turns out to be about 0.9591. I like to keep at least 4 decimal places here. Okay, and then remember we can undo this by doing sine inverse of this on both sides. But here's where some of the issues happen. Okay, so if I do sine inverse, which is second function sine of 0.9591, what I get is that C is about, and if we round, I'm doing these problems out of the exercise set, and I think the directions are to round angles to the nearest degree and sides to the nearest tenth. So if I rounded that to the nearest degree, it would be about 74 degrees, okay? All right, so then you might be thinking, all right, so now I know that's 74, and so let me just go ahead and take 180 minus 46 minus the 74, and that tells me that B has to be 60 degrees, and move on, and then find out that you're wrong. Okay, so I'll show the work I did to get B. Okay, minus 46 minus the 74, and that's 60 degrees. Okay, but that turns out to be incorrect. And let me show you how you know you did something wrong, but then what would be a better plan in order to be able to fix it. Okay. Move that up a little bit for us. Okay. All right, so here's how it's wrong. Okay. When you look at the sides, the longest side should be opposite the biggest angle, and it is. But then do you see how B being 60 is opposite the shortest side and A is 46? That can't be right. All right. So what was going on is this, that here, this is where the issues are. Let me do it in a bright green. Right in here is where the issues always happen. And that's because when you think about that angle of 74 degrees, it's over here, right? This is 74 degrees. Well, there's an angle over in the second quadrant that has the same sign. Remember how the sign, I think of it like this. That's how I always remember it. You know how the sign is associated with the y coordinate? The y coordinate of those points would be the same. So the angle in the first quadrant at 74 degrees, this angle, and the angle in the second quadrant over here have the same sign, and it could potentially be the measure of the angle in this triangle. And so to find that, I know this would be 74 right here. So let me subtract 74 from 180, and that gives me that this would be 106 degrees. I got it by taking 180 and subtracting that 74 right there to see what that remaining piece had to be. And it turns out that C at this point could be 74 degrees, or it could have been 106 degrees. And you can't tell initially. So you go on and you find B for each. And if you used the 106, then when we did that, the B would turn out to be only 28 degrees. And so up here, instead of 60, it would be 28 degrees. And then the biggest angle turns out to be opposite the longest side like it's supposed to be, okay? Well, you want to try to avoid this, okay? We can avoid this. We can avoid this situation by just doing this instead. The reason I got caught on this one is I just kind of randomly picked C to go on and use the law of sines with. So the idea is, well, don't just randomly pick something. Think about it a little bit and try to avoid this, okay? We can avoid this by using the law of sines to get the smallest angle first. We know it has to be acute. You can't have two obtuse angles. So that's the idea. We can avoid this situation by using the law of sines to get the smallest angle first, okay? All right, so here's what we should have done. Let me go ahead and leave that, and I'll just put in some spaces here, and we'll do it again from where we were at, okay? So let's just copy what we have right here. Okay. Okay, let me move it down, and let me show you then what your plans should be. All right, so you should do like we did before. So do the same thing as we did before. Do the same as above to get A. So I won't redo that. We've already done that, okay? All right, so we find out A is 6, and we already knew that B was 4, C was 8, and A was 46 degrees, okay? And so now we're moving on. And what I did before is I just said, okay, well, let me find C. But here's the deal. I know, so I'm going to write it. I know B has to be acute since only one angle in a triangle can be obtuse, okay? Obtuse, sorry, I'm having trouble writing. Okay. So do the same as above, what we did to get A. But I know B has to be acute since only one angle in a triangle can be obtuse. So I'm going to use law of sines to get B since it's opposite the smallest side. Okay, so I know it has to be acute. All right, so I'm going to take and set up my proportion. So I'm going to say sine of B over 4 equals, oops, put that in the wrong spot, equals the sine of 46 degrees over 6. And I'll solve that. And I'll find out that the sine of B equals 4 times the sine of 46 divided by 6. Okay, I didn't enter it right. 4 times the sine of 46 divided by 6 turns out to be about 0.4796. Remember, that's not the answer. That's the value of the sine of the angle. So you have to do inverse sine of that. So you have to do sine inverse of these. And this is where some of the issues come in, right? Because there's two potential angles you could have. Okay. The calculator only gives you the acute one. The calculator only gives you the 29 degrees, okay? But, okay, so that's here, and there would be an angle over in the second quadrant that could be an angle of a triangle potentially, but you don't need that. You don't need to even check on that because you know B has to be acute, so you don't even have to go there, okay? So that has to be B. So that saves you a lot of thinking. And then once you know B, you're just going to go in and get C by taking the 180 minus the 46 minus the 29. Okay, and that gives you the 105 degrees for C. Now, I will say, when you are finding the answers to these, if you go and you use a different route, like when I did this earlier on purpose the wrong way, I wound up with C being 106, and I was doing all my rounding appropriately and everything. So it can happen if you wind up going a different route just because of rounding off. All right, so let me just recap this. If you think strategically on this, you can save yourself a lot of work. So we had to do this, find A. This was the only way to do that, and that was the only way to get started. So once we found A, though, we had a choice about whether we were going to get angle B or angle C. All right, the best thing to do is to look for the smaller of the two angles first, and you would know which one's smaller based on which one's opposite the shortest side. So B is opposite the shortest side. So really, I shouldn't have done this right here if I had been thinking. And the reason I shouldn't have done this is the largest angle, maybe it's acute or maybe it's obtuse. You can't tell until you finish the whole problem and you check it. So if I had made a better decision like I did here, I would have done A like I did before, but I know that B has to be acute since it's since only one angle in the triangle can be obtuse, and B is the opposite the shortest side, so it has to be acute. So I'm going to use law of sines to get B, and if I did that, then there's only one possibility here. I don't even have to consider the obtuse angle for that. And then I'm able to go in and find the value for C. And I didn't even have to do that whole thing that can be so tricky, okay? All right, same thing can happen, okay, but you need a different approach here. Same thing can happen on this, okay? So here's what you'd want to do on this one. Let me go ahead and just go right to the correct approach and not show you what can happen if you do the wrong thing. I'll just tell you after the fact what can happen. All right, what you want to do here is you don't want to start by finding the angles that are the smaller angles. And don't base that on what the triangle looks like. Base that on the lengths of the sides. So do you see how the opposite angle A, the side is only 4, and the side opposite angle B is 6, and angle C is 9. So C would be the biggest angle and the only angle that could potentially be obtuse. So if you will start with that one, the law of cosines is a good thing to use. You don't have to do this part right here, because if you think about the cosine, your angle could be anywhere in quadrant 1 or 2 and be an angle in a triangle. But with cosine, an angle over here and its related angle over here, okay? Those two angles don't have the same cosine. They just have the same sign. So when you wind up finding angle C, the C that you get, if it's obtuse, it'll show up that way without you having to do any extra thinking, okay? All right, so that's what you want to do. Start with the biggest angle. So when you're given one like this, you want to find the largest angle first, in case it is obtuse, so that you don't have to deal with what can happen when you go to use the law of sines. All right, so that means I'm gonna set it up where the side C is on a side by itself. Then I would put side A and B over here. Doesn't really matter the order you do those. And I'll have cosine C. Now this algebraically requires a little more work, okay? So this would be 81 equals 16 plus 36. That's 8 times 6, so that's 48 cosine C. Now, at some point, people sometimes do better when the unknown is on the left-hand side. So you may want to just switch the two sides of the equation around at some point. Okay, I'm going to go a little bit further before I do that. I'm going to add the 16 and the 36. That gives me 52. Okay. And then at this point, maybe it would help you if I just flip the two sides. I'm not moving. I'm not like adding the opposite. I'm just saying if these are equal, it doesn't matter which side they're on. Okay, so there we have the same problem as before, but it just sometimes helps people that they're trying to get the C by itself. So work on isolating cosine C first. Okay, so you got several things to do. Let's take away 52. Okay, when I do that, I'm left with negative 48 cosine C equals 29. Okay, so now I'm going to divide by the negative 48 on both sides. And so I'm going to get cosine C is 29 divided by 48, and it'll be negative. I just don't like to type in the negative. So it's a negative 0.6042, and I would keep at least 4 places. I actually hang on to all the decimals. And see that negative right there? That tells me that I am going to be getting an angle over in this second quadrant. So it'll give me back an angle in either the first or the second, and this one will definitely be in that second quadrant. Okay, and so it wound up not, so I must have not typed in the negative. So let me try that again. So I have negative 0.6042. Okay, and I want to do the second cosine of that. Okay, and so that turns out to be about 127.2, and it said to round to the nearest degree, so I'll just say 127. Okay. All right, I knew I made a mistake. I had left the negative out of it because it gave me something in the first quadrant. All right, so do you see what this does for us? Is when we're up here trying to fill in the different pieces, 6, 9. If we'll find the angle corresponding to the longest side, then if it's obtuse, it'll come out of the law of cosines without me having to consider the two possibilities like I do with the law of sines. I don't know if that makes sense, but when it happens to you enough, you'll appreciate the fact that if you make the right decision in the beginning, it can save you a lot of work. Okay. All right, so then to finish this one, I could use the law of sines, and I don't have to worry. I know both A and B have to be acute. They have to be in the first quadrant, so I don't even have to look for the angle over in the second quadrant. So we just go in, and it doesn't matter which one you did. So if I did sine B, I would put it in the top left corner, though, over little b equals sine of 127 over 9. See how we're jumping over to the law of sines now just because it's a little easier. So multiply both sides by 6. And then get the value of that. Keep some accuracy on that for now. And then do the inverse sine of 0.5324. And so I get that B is about 32 degrees. Now, don't forget what I did was sine inverse on this side, sine inverse here, and that's where that 32 degrees came from. All right, so now I know that. And then A is easy because you know all three of the angles have to be 180. Right, and so I get A to be 21, and see how biggest angle, medium-sized angle, smallest angle, they're matched up like they need to be, okay? And to get A, I did that last. I just did 180 minus the 127 minus the 32. Okay. All right. So if you approach the problem strategically, you can not run into that tricky thing that can happen on these, where you have to consider whether to use the acute angle that you get when you do inverse sine, or whether you need to take the angle related to it over in the second quadrant, okay? So if you're given a side situation, okay, this is important. Find the largest angle first in case you have an obtuse angle. And then with law of cosines, when you're doing side angle side, you're going to use the law of cosines to get that third side, but then find the acute angle. That you'll have one angle. Find the remaining angle that you know has to be acute. And then that means when you get here, you don't even have to check that angle over in that second quadrant. Okay. So use the law of sines to get the next smallest angle. Okay, or the remaining angle that's the smallest. Okay, all right, so let me stop this.